So you flip the breaker, test the circuit, and your meter reads 0 volts. You reach in to disconnect the wires and suddenly, you're on the ground wondering what just hit you. Welcome to one of the most dangerous assumptions in electrical work. Thinking that a de-energized circuit is actually safe to touch. In today's Safety Toolbox talk, we'll look into a reality that too many electricians learn the hard way. Capacitors store electrical energy like a battery, except they can discharge it all at once. When you shut off power to a circuit, any capacitors in that system are still holding a charge. They don't care that you opened the breaker. They don't care what your meter says at the panel. They're sitting there fully loaded, waiting for someone to complete the circuit with their body. Think about this for a second. You could have a motor drive that's been sitting unpowered for 10 minutes. Your voltage tester says it's dead, but inside that drive, capacitors are holding hundreds of volts, sometimes even after an hour or more. The moment you touch the wrong terminals, that stored energy dumps through you faster than you can pull your hand back. This isn't a theoretical problem. This happens to experienced electricians who do everything else right. Let's talk about where these hazards hide because they're not always obvious. Motor drives and variable frequency drives are probably the most common culprits. These devices use large capacitors to smooth out DC voltage for controlling motors. When you shut down the drive, those capacitors stay charged. Some drives have built-in discharge resistors that bleed off the energy over time, but not all of them do. And even the ones that have them can fail, leaving you with a fully charged capacitor bank that your meter won't detect from the input side. Power factor correction equipment is another big one. Facilities use these to improve electrical efficiency, and they're packed with large capacitors. You might be working on what looks like a simple disconnect or breaker, but downstream, there are capacitors holding serious voltage. Shut off the power, and those caps just sit there energized until something or someone gives them a path to discharge. Lighting ballasts, especially older ones and high-intensity discharge fixtures, also use capacitors. You'd think a light circuit would be simple and safe once the switch is off, but that ballast capacitor can hold enough charge to give you a serious shock or worse. Same thing with electronic equipment power supplies. Computers, servers, industrial controls, even that innocent-looking power supply on a piece of test equipment can have capacitors that stay charged long after you unplug it. Here's where electricians get into trouble. Standard voltage testers measure potential between 2 points at the moment you test them. If you're testing at a panel or disconnect, and the capacitor is downstream behind some resistance or on the DC side of a rectifier, your meter might not see that stored energy. It tells you 0 volts, and you trust it because that's what the tool is supposed to do. But it's only measuring where you put the probes, not what's waiting for you inside that enclosure. The scariest part about capacitor discharge is the speed and intensity. Unlike touching an energized circuit where you might have a split second to pull away, capacitor discharge happens instantaneously. All that stored energy dumps in microseconds. Your muscles don't have time to react. Your heart doesn't have time to adjust. If that discharge path goes across your chest, you're looking at potential cardiac arrest from what you thought was a dead circuit. So how do you protect yourself from something you can't see with a standard meter? First, you need to know what equipment you're working on. If there are capacitors involved, and in modern electrical systems there almost always are, you need to treat that circuit as potentially energized even after you've locked it out. Many motor drives and power supplies have indicator lights that show when capacitors are discharged. But don't bet your life on a light bulb. Those indicators can fail or lie. The proper procedure is to wait. Most equipment manufacturers specify a discharge time, usually 5 to 30 minutes depending on the capacitor size and discharge resistor values. You lock out the equipment, you test it, and then you wait the specified time before you touch anything. Yes, this feels like wasted time when you're trying to get work done, but it's not wasted if it keeps you alive. For equipment without specified discharge times or when you're not sure what's inside, 15 minutes is a reasonable minimum. For large industrial drives or power factor correction banks, you might need to wait even longer. Some electricians carry shorting sticks specifically designed to safely discharge capacitors before working on equipment. These are insulated tools with a resistor built in that lets you deliberately create a discharge path without putting yourself in series with that energy. You can still get hit by stored capacitor energy if you don't account for it specifically. This is one of those hazards that punishes you for following most of the safety rules, but not all of them. The bottom line is simple but critical. De-energized doesn't mean safe when capacitors are involved. If you're working on any equipment with motor drives, power supplies, lighting ballasts, or power factor correction, you need to assume capacitors are present and still charged until you've either verified discharge or waited long enough for them to bleed down naturally. Your voltage tester can't always see stored energy, which means you need to use time and proper procedures as your real protection. Taking an extra 10 or 15 minutes might feel unnecessary, but it's a lot better than being the electrician who learned about capacitor discharge the hard way, so please stay safe on the job.
Did you know that in 2020, a study conducted by the Associated Builders and Contractors found that daily safety toolbox talks lead to a remarkable 82% reduction in total recordable incident rates compared to those conducted monthly? The study shows that the frequency of toolbox talks directly correlates with incident rates. Consistent safety toolbox talks lead to less accidents, which is why many companies this year are using Safely EO to create and schedule these talks weeks and months in advance, so your team will be consistently reminded of the job hazards and safety protocols. You get access to Safely EO's Toolbox Talk library that comes with hundreds of text-based and video-based toolbox talks that covers any industry. The Toolbox Talk app makes it easy for your employees and supervisors to consume safety talks from their own mobile devices and acknowledge its completion at the click of a button. All completed safety talks are tracked, and the data can be exported and available for use. The platform digitizes your safety talks process, so you can focus on what really matters, keeping your team safe and informed. Don't wait until it's too late. Workplace incidents can cost your company millions in liability, lost productivity, and damaged reputation. To learn more, just click the link in the description of this video to request a quick demo.